everyone, thank you so much for clicking onto the video. Today we're going to be looking at alcohol production, so here are the learning objectives. We're first going to learn about how alcohols are produced industrially by hydration of alkenes in the presence of an acid catalyst. And we're also going to look at the production of ethanol industrially by fermentation of glucose and the conditions for this process. And we're also going to be looking at ethanol produced industrially by fermentation and how it's separated by fractional distillation and can then be used as a biofuel. So by the end, we should be able to explain the meaning of the term biofuel, justify the conditions used in the production of ethanol by fermentation of glucose, write equations to support the statement that ethanol produced by fermentation is a carbon neutral fuel, and give reasons why this statement is not valid, outline the mechanism for the formation of an alcohol by the reaction of an alkene with steam in the presence of an acid catalyst, and discuss the environmental issues linked to decision making about biofuel use. Now I'm going to introduce alcohols. So alcohols are a homologous series with the general formula CnH2n+1OH. So the first alcohol we have is methanol. So that would be when you sub in n equals 1. So we would get a formula of CH2 multiplied by 1 plus 1 OH. So methanol has the formula CH3OH. Alcohols are produced industrially by hydration of alkenes in the presence of an acid catalyst, and they can be classed as primary, secondary, or tertiary alcohols. So for primary alcohols, the carbon which is attached to the OH only is attached to one alkyl group. So we have the carbon and the OH, and we have the carbon is attached to another two hydrogens and only one alkyl group, which is what the R stands for. So this is a primary alcohol. The secondary alcohol is where the carbon which is attached to the OH is attached to two alkyl groups. So we have the carbon attached to the OH, and then we have one alkyl group and another alkyl group and a hydrogen. And so this is a secondary alcohol. And then for the tertiary alcohol, we have three alkyl groups attached to the carbon, which is attached to the OH. And so we have carbon and the OH, and now we have three of these alkyl groups. So this is a tertiary alcohol. Alcohols have a higher melting and boiling point compared to their corresponding alkane, and this is due to hydrogen bonding. And we get hydrogen bonding between hydrogen and a very, very electronegative atom. And so because we have OH bonds, hydrogen bonding is present. And this is opposed to the weaker van der Waals forces between the alkane molecules, which take less energy to overcome and so have lower melting and boiling points. The shorter alcohols are soluble in water, and this is because they can hydrogen bond with the water molecules. However, the longer alcohols are insoluble in water, and that is due to the longer hydrocarbon chain, which is insoluble. Now we're going to look at alcohol production. So we're going to be looking at producing ethanol. Now, ethanol is a very useful alcohol as it's used in aftershaves, perfumes, and solvents in cosmetics. Now, sometimes you're asked about the uses of ethanol, so it's quite good to remember one or two of these examples. And we can produce ethanol in two different ways. The first way is by fermenting glucose, and the second way is by hydrating ethene with steam and the presence of an acid catalyst. So we're first going to look at fermentation. So we break down sugars in the absence of oxygen to produce ethanol and carbon dioxide, and it's also in the presence of yeast, which contains the enzymes necessary for this process. So key things to remember are that we're breaking down sugars in the absence of oxygen, and we produce ethanol and carbon dioxide, and we also use yeast. And this process is called anaerobic respiration. So the general formula we have here is that we have glucose and we form 2 moles of ethanol and carbon dioxide. So the sugar, which is the glucose, comes from sugarcane or sugar beet. And some conditions that we need to know is that the temperature needs to be maintained at 35 degrees. And this is because the reaction is too slow at lower temperatures, and so it costs more to keep it running. And at higher temperatures, the enzymes in the yeast would be denatured, and so we wouldn't actually get a reaction. And also, we have to have no air present, as this would oxidize the ethanol produced into ethanoic acid, which we don't want. And we can produce 15% alcohol using fermentation. And this is because the alcohol would poison the enzymes if the concentration was any higher. And so that means that in order to obtain a higher concentration of ethanol, we need to distill the ethanol after we've fermented the glucose. And now we're going to look at hydrating ethene, which is the second process that we can do to form ethanol. So with hydrating ethene, firstly, the ethene is obtained from crude oil by the thermal cracking of the longer hydrocarbons. And ethene can then be reacted with steam and an acid catalyst. So we're using phosphoric acid. The ethene is hydrated as water is added across the double bond. And because the water is acting as an electrophile, this is actually an electrophilic addition reaction. So in the equation overall, we have ethene added with water in the presence of this phosphoric acid catalyst to form ethanol. So now we're going to have a look at the mechanism. So first we have ethene. And then we have a H plus from the catalyst, from the phosphoric acid. So we have this H plus, and because the double bond is an area of high electron density, that means that this H plus is attracted to it. And so what happens is that the electrons from the double bond move to this H plus. And so this forms a carbocation. So I'm adding the hydrogen onto the first carbon, and so the double bond breaks and we've only got two hydrogens on this carbon. And so this carbon is now positively charged because we've lost some electrons. And now what happens is that the water we're adding is acting as an electrophile. So we have water, and the oxygen has two lone pairs of electrons. And so these, a pair of these electrons is then attracted to this carbon with a positive charge. And so it bonds to this carbocation that we formed. And so we form CH3, CH2, and then the oxygen with the two hydrogens still attached. We can also put partial charges onto the electrophile. So we could say that the hydrogens are partially positive and the oxygen is partially negative. But it doesn't really matter if we put them or not. And then this means that this oxygen is now positively charged because we've given away some electrons. And so now what happens is that this pair of electrons then moves towards this positive oxygen. And what we get is we get this. Well, we form the ethanol. So we have CH3, that hasn't changed, and then CH2, and then we have OH. So we've lost that hydrogen which was attached to the oxygen before, and now it's formed a H plus ion because it's lost the electrons because the electrons in the covalent bond have moved towards the oxygen to make it neutral, and so a hydrogen plus ion forms. And so again, this is an electrophilic addition reaction. And this is because the attacking group is an electrophile, so it's the water, and we're adding the water across the double bond. And so this is why it's an electrophilic addition reaction. Because this H plus is regenerated at the end, we call this a catalyst. And so this is why we have that phosphoric acid as a catalyst, because the H plus is what we're using, and it's being used up and regenerated at the end. Now we're going to look at the methods of producing ethanol and compare them. So we have the industrial process, which is the process that starts from crude oil. So because crude oil is a non-renewable source, it's not as good as fermentation, because sugars are a renewable source and so they won't run out. For the industrial process, the method of manufacture is the cracking and hydration of ethene using phosphoric acid catalyst, whereas for fermentation, it's fermentation and then distillation if we want a higher concentration of ethanol. The conditions that we need for the industrial process are high temperatures, so around 300 degrees, high pressures, so 70 atmospheres, and a strong acidic catalyst, so we use concentrated phosphoric acid. Whereas for fermentation, the temperature we use is about 30 to 40 degrees, and we don't use air, and also we need yeast. And the type of process for industrial is continuous, whereas for fermentation, it's a batch process. So we finish one batch and then we have to start again with the next batch, whereas for industrial, it just keeps on going. And then the purity for an industrial process is 100%, so we get 100% ethanol, whereas for fermentation, we only get up to 15% before we start killing the enzymes. And so we need distillation for the higher purity again. The rate of reaction for the industrial process is very fast, whereas for fermentation, it's very slow. So now I'm going to talk a bit about the advantages and disadvantages. So the advantages of the industrial process are that it's a fast reaction, and it also forms a much purer product. Also, it's a continuous process, and so this means cheaper manpower. However, the disadvantages are that there's a high technology equipment needed, which is expensive initial costs. And also, ethene is a non-renewable resource, and so it will become more expensive when the raw materials start to run out. Another disadvantage is that high energy costs for pumping is needed to produce the high pressures. Whereas for fermentation, the advantages are that sugar is a renewable source, so we can always source it. And also, production uses a very low level technology, so cheap equipment is needed. And the disadvantages are that it's a batch process, which is very slow, and it also gives high production costs. It also produces ethanol, which is not pure, and it needs purifying by fractional distillation, which makes the process even slower because you need to do 2 steps. And it also depletes land, which is used for growing food crops, because we'll be growing more crops to ferment to produce ethanol. Now we're going to have a look at biofuels. So biofuel is a fuel which is derived or produced from renewable biological sources, so for example plants. And they are described as being carbon neutral. And what this means is that the carbon dioxide released into the atmosphere during combustion is balanced by the carbon dioxide absorbed from the atmosphere where the plant is growing and photosynthesizing. So there is no net gain or loss of carbon dioxide. And so we have 2 reactions that are happening. We have the photosynthesis, where the carbon dioxide is being absorbed from the atmosphere, and fermentation and combustion reactions, where carbon dioxide is released into the atmosphere. So first we're going to start off with the photosynthesis. So we have the carbon dioxide, and this reacts with water, and this forms glucose and oxygen. So we see that 6 moles of carbon dioxide are being taken in. And now when we look at the fermentation and combustion, for fermentation, we get the glucose going to form 2 moles of ethanol, so that's C2H5OH, and also 2 moles of carbon dioxide. And then for the combustion of this alcohol, we then have 2 moles of alcohol, so this ethanol, and we're reacting it with 6 moles of oxygen to form 4 moles of carbon dioxide and also 6 moles of water. And so we can see that we're forming 2 moles of carbon dioxide here and 4 moles of carbon dioxide here. And so 6 moles altogether of this carbon dioxide are released back into the atmosphere. And so we can see how this can be seen as carbon neutral. However, there are some things which might not make it carbon neutral because this hasn't taken into account the transport of the crops and the fuels, and also the need to process the crops. And all of this could be provided by fossil fuels because if we're running car engines, then that could have came from burning of fossil fuels, which isn't renewable, and so it wouldn't have been carbon neutral. And there are also some issues to using biofuels. So the first is that the demand for biofuel crops would mean there'd be a greater demand on rainforest land. So we'd have to chop down some rainforests to be able to grow crops to turn them into biofuels. And also, some people morally object to using food crops to produce fuels. And this is because it could cause food shortages or increase in food prices. So these 3 equations are really important to remember because they come up quite often in exam questions when you're asked about the carbon neutrality of biofuels.